Welcome back. This is Ms. Gradincic. I am the 7th grade and 8th grade math teacher at Syracuse STEM at Blodgett. This video lesson is for my 7th graders. My 7th graders have an assignment to work on at home. And in this homework assignment, you're being asked to look at these 3 shapes and to determine whether or not copy 1 and copy 2 are scaled copies of the original. So in this example, we are going to be comparing corresponding parts of copy 1 and copy 2 to those parts on the original. A corresponding part is simply a part on the copy that is in the same position as that part on the original. So let me show you that with a different example. If I were to, for example, draw a triangle that has the following side lengths. So let's call this triangle A, B, and C. We give our triangles and our shapes, our figures in math, we give them names. So the way we would label this or name this triangle is like this. This is a triangle A, B, C. The side lengths of this triangle, let's say that they are 3, 3, and 4. We can say that this line segment here on triangle A, B, and C is 3 units long. So segment AB or line AB is equal to 3 units. We can say that this line segment here, segment BC, is also 3 units long. And line segment AC, this is how we would write it, is 4 units long. Now if I wanted to scale this triangle, and if I'm using a scale factor of 2, scale factor 2, what this means is that I'm going to multiply every one of these side lengths by 2. So 3 times 2, So 3 times 2 is equal to 6. And 4 times 2 is equal to 8. So these are going to be side lengths of my scaled copy. Scaled copy is simply a shape that you get after multiplying the original with a scale factor. In this case, we chose our scale factor to be 2. So our new scaled copy is going to look like this, approximately like this. Okay? We can call this triangle D, E, and F. This is how we write that, triangle D, E, and F. We know that triangle D, E, and F has line segment D and E, and DE line segment is 6 units long. That is this side length right here. This is a corresponding line segment. A corresponding line segment, again, is a line on the scaled copy. So this is our scaled copy. Corresponding part is simply a part on scaled copy that is in the same position on the copy as it is on the original. And I just realized that I wrote Corey, not copy, so let me fix that. All right. So how about line segment EF? Line segment EF is going to be 6 units long. This is a line segment that corresponds, oops, I accidentally erased that. So line segment EF is also 6 units long, and it corresponds to this line segment here. Why? Well, that's because it is in the same position as line segment BC on the original. Lastly, we have line segment DF, and that line segment is 8 units long. this is a corresponding part. Line segment DF is a corresponding line segment to line segment AC on the original. So what you're being asked to do in this assignment is to look at these three shapes and to find the corresponding parts in copy 1 and copy 2. Another thing that we can look at on the original triangle here and the scaled copy are corresponding angles. Corresponding angles, just like corresponding parts, are angles that are in same location on the scale copy as they are on the original. So for example, we have angle A, B, and C. The way we write that is like this: angle A, B, C. That is this angle right here. The corresponding angle on the scale copy is going to be angle D, E, and F. So angle D, E, and F corresponds to angle ABC. Can you find other corresponding angles on the scaled copy? Remember, you're looking for angles that are in the same position as the angles on the original. So for example, if we have angle BAC, what would be the corresponding angle on the scaled copy? So we're looking at this angle here. All right, that is angle BAC. The corresponding angle on the scale copy is going to be EDF. So now we can do that with our homework assignment. We can look at these three shapes and we can compare different corresponding parts. So for example, in this table, we're looking at point P. Point P on the original has its corresponding part in copy 1 and copy 2. The corresponding point on copy 1 is point F because it is in the same location as point P. The corresponding part or corresponding point on copy 2 is point Z. If we look at the angle KLM on the original, the corresponding angle on the copy 1 is angle A, B, and C. And then you would just continue that way with all of the corresponding parts. Now we have this nifty little tool here where we can actually measure the corresponding angles. Now remember, a scale copy is the same shape as the original, except that it's bigger or smaller than the original. That is because we multiplied the original with a scale factor to get a scale copy. So if I wanted to verify that a corresponding angle on copy 1 or copy 2 is the same size as the angle on the original, I can use this little tool here. I can line it up with this corresponding angle, angle D, E, and F, and I can make sure that it's lined up perfectly. Okay, you can see that there. And now I can take this little tool and try to line it up with the angle NOP on the original, and I can see that they're exactly the same size. If I take that nifty little tool down to corresponding angle on copy 2, the angle X, Y, and Z, I can see that that angle is bigger than the original angle NOP. What that tells me is that if the angles are different, if they're different size, it tells me that that copy is not a scale copy of the original.